Hi everyone, welcome to lesson on inverses of functions. All right, so today we're talking about what the inverse of a function is. So let's get a formal mathematical definition. So by mathematical definition is the inverse of a function is formed by switching the x and y coordinates. Now another way we can think about this is that the inverse is saying that there's a reflection over the line y equals x. Okay? Because when I reflect over the line y equals x, I'm actually switching the x and y coordinates. So for example, here's my quadratic parent function. And then when I reflect it over the line y equals x, it becomes like this, right? So I'm switching the position of the x and the y coordinates. All right, so let's take a look at some coordinates and we're going to find the inverse. The way we denote inverse is we do the same function notation, but with a little -1 at the top. All right, so my inverse. So my first point was 0, 1. My inverse is going to be 1, 0. My second point was 1, 3. My inverse is going to be 3, 1. 2, 5 becomes 5, 2. And 3, 7 becomes 7, 3. So there's my inverse when I'm using coordinate points. What we're really going to focus on today is we're going to focus on how we find the inverse algebraically. So there's 3 steps that we need to follow anytime we find the inverse algebraically. Those steps are the following. Step 1 is we're going to change the f of x to a y. Then we're going to switch the position of the x and y, and then we're going to solve again for y. So let's go ahead and go through those steps. So the first step is I'm going to change my f of x to a y. All right, and I'm going to color code this. Step 2 is to switch the x and the y. And step 3 is to solve. So let's go pink. So we're going to solve just like we would for any equation. The only difference is we're solving for y. So I get x plus y is equal to 4y divided by 4. I get y is equal to x plus 2 over 4. Now I can't leave it as y is equal to because I'm talking about the inverse. So my final answer, I'm going to write the inverse notation. Again, to distinguish between my inverse and my original function. Okay, let's try another one. So step 1, change the f of x to a y. Step 2, switch x and y. And step 3, we're going to solve. So for this one, I'm going to solve by cross multiplying. You could have also taken the multiplicative inverse. And I'm solving for y. So I get my inverse function is equal to 3x minus 7 over 4. Okay. And what I want you to notice is that like my inverse is kind of similar to where I started. We have the same numbers, but they're just in different orders or maybe working on different operations. Same thing for the second one, letter B. I have 4, 7, and 3. In my inverse, I still have 4, 7, and 3, but again, maybe they're in a different order. Maybe they're using a different operation. So let's think about what actually the inverse is telling us to do. So the inverse is, yes, the switching of the x and the y coordinates, but it's also telling me to do things in the reverse order. So if I were to think about this verbally, all right, let's think about this verbally. And I'm looking at this left-hand side equation, 2x plus 3. What I would do is I would start with an x. All right, so I'd just start with x. Then I would build upon this function. So the first thing I would do is start with x. Well, it's 2 times x, so then I would multiply by 2, which now gives me 2x. Then I would add the 3 on, so I get 2x plus 3. And I would end with my equation, which is y is equal to 2x plus 3. And I'd end with y. So here would be my steps if I was trying to write an equation. Now, the inverse essentially tells me to do the opposite. So what that means is I'm going to work backwards, right? So let's see. So I'm working backwards now. So instead of ending with y, well, what's the opposite of that? It's starting with x. So my function would start with x. Next, again, I'm working backwards. So I started with 4. Now I'm going to 3. So I added 3. What's the opposite of that? The opposite is subtract 3. So it becomes x minus 3. Next, in my original, I multiplied by 2. So what's the opposite of multiplying by 2? It's dividing by 2. So I'm building my function. I'm just doing it in the reverse order. And I started with x. So the opposite of starting with x is ending with y. So I get y is equal to x minus 3 divided by 2. Here is my inverse function. So this is another way to do it if you think about it verbally, and I think that way is pretty cool because we're actually seeing the function being built and then we're kind of breaking it down. All right, try the next one on your own if you can. All right, let's run through it. So the next one is 2x squared plus 5. So let's think about what we did first. So here we started with an x. Then we squared it. Then we multiplied it by 2. And last we added 5. And we finished with y equals. So I'm going to work my way backwards. So instead of ending with y equals, I'm starting with an x. Instead of adding 5, I'm now subtracting 5. Instead of multiplying by 2, I'm now dividing by 2. All right, so now I'm squaring something. So I have x minus 5 divided by 2, but what's the opposite of squaring something? Yeah, the opposite is square rooting it. All right, and then last but not least, I started with an x here. Let me write that in. I started with an x. So my opposite of starting with an x is ending with a y. So here's my inverse. Now, if you don't like to think about this verbally or in the steps like this, you can always go back and switch the x and the y and solve. That works as well, but this is just another way to think about the inverse.